What's the answer?
The answer is 4. Okay, so I'm just going to go jump right in and tell you the derivative of sine u is cosine u times u prime.
Cosine u times u prime.
Notice that the argument, you know how I talked about you can never change the argument of a trig function without using an identity? Even with derivatives, that still holds true. If it's the derivative of sine of x squared plus 5, the argument of cosine will be x squared plus 5. The argument does not change, even in the derivative. Then you multiply by its derivative on the outside. So the derivative of sine is cosine. The derivative of cosine is?
Sine.
Very close. The derivative of cosine is negative sine. So the derivative of cosine u is negative sine u times u prime. All right, we're going to jump in and have a little fun with derivatives. So we are going to derive the derivative of tangent. Tangent is the same thing as what over what?
Sine over cosine.
Hey, so we could figure out the derivative of tangent simply by using quotient rule on sine over cosine, right? So I'm going to take a minute to figure out the derivative of tangent.
Should we put sine u so it's more
No,
accurate?
it's sine x.
Hey, early release date is
So confused.
What is the derivative of sine x?
Oh, you're right.
It's cosine x times 1, which is just cosine x. You can talk to each other too. You don't have to do it in complete isolation.
What are you going to do this Wednesday for early release day, Jacob?
I'm planning on dealing some meth.
You make good money doing that.
You know, the actual money gets from like, you start off as like a meth dealer and then you work your way up.
No, really.
I'm just saying, Breaking Bad had it wrong. Heroin, since I think.
What are you doing this early release day? You going to play some fall ball, bro? How'd y'all do? Heard y'all lost the game.
Well, we don't know what X is.
You're on the basketball team?
It would be plus.
No.
But because we're playing it with the X
What?
we're playing the first game of the season, bro.
Did y'all beat them like 17-5 last year? I thought they scored 5 times on them. Wait, but y'all lost all your time, bro.
Ah, that's what we're missing dates.
Y'all lost New Brothers. Y'all lost Cole, y'all lost Chad.
All right, good. So here we go. What is the derivative of sine x? Cosine x, right? Times 1 times cosine x minus sine x times the derivative of cosine x, which is negative sine x, all over cosine squared x. Now, a mistake that I did see on some of your quizzes, not many, just a couple, is misunderstanding something. Cosine x squared is not the same thing as cosine squared x, right? Cosine squared x is the entire cosine being squared, right? So if you see just the x squared, this is not the same thing as this, right? And this is not the same thing as this. So I had people misinterpret in both directions on the last quiz. So just be careful where that squared is, if it's just on the argument or if it's on the whole cosine. Okay? Okay. All right. So here's what we get for this one. we get cosine squared. By the way, don't forget, be very careful when you're multiplying by a negative. This is negative sine x times negative sine x. It's not sine minus sine. This is not subtraction, it's multiplication. So don't turn your multiplication into subtraction. I saw that a lot too, where people would drop parentheses and all of a sudden their multiplication became subtraction. So be careful that it stays multiplication. So you get cosine squared plus sine squared over cosine squared. Hey, anyone know what cosine squared plus sine squared is?
1.
It's 1. So this equals 1 over cosine squared, which is the same thing as? This is secant squared. So are you telling me the derivative of tangent is secant squared?
Yes.
And it is. So the derivative of tan u, remember u represents some function that is in terms of x, right? So this argument here could just be x. It could be x squared minus 5. It could be whatever it is. U represents some function. So the derivative of tan u is secant squared u times the derivative of the argument times u prime. All right, I'm going to quickly tell you the rest. The derivative of cosine, and you find all the rest the exact same way, right? Actually, you know what? I'm not going to tell you cosecant. I'm going to make you derive it. So, but we're going to do it slightly different. Let's just do cosecant x. So if y is cosecant x, cosecant equals what? 1 over sine. I'm going to write this as sine x to the negative first power. And I want you guys to find the derivative using chain rule. Chain rule. Put the negative in front, negative 1 times something to the something. Okay? So take a moment, find the derivative of sine raised to the negative 1 power. Okay, y'all done? Need another minute? Okay, so first thing we do is we write negative times sine x to what power? Negative second. Remember, subtract 1 from the power. Times the derivative of sine x, which is?
So we want to go.
Cosine x. So what we end up with is negative cosine over sine squared. Did you guys get that far? We're good? Okay. Now, there's a couple ways to write this. I break this up to write it the way that I was taught, which is to think of it as 1 over sine times cosine over sine, which equals negative cosecant cotangent. So, the derivative of cosecant u is negative cosecant u cotangent u times u prime. And to find these, it's the exact same way, right? So the derivative of secant u is secant u tangent u times u prime. Hey, if the derivative of tan is secant squared, what do you think the derivative of cotangent is? Cosecant squared. It's negative cosecant squared u Alright, so in a nutshell, derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, derivative of cosecant is negative cosecant cotangent, derivative of secant is secant tangent, and derivative of cotangent is negative cosecant squared. You will have to memorize these 6 derivatives by tomorrow. But you'll use them so much tonight that it'll be easy. Okay? Okay. Good. Let's start using them. By the way, I want you to notice something in common with all of the functions where the name of the function starts with a C. What do you notice that's in common with all of their derivatives?
Negative.
They're all negative. The derivatives that are negative are all derivatives of functions where the name starts with a C. Cosine, cotangent, cosecant, all of those have negative derivatives. All the rest of them have positive derivatives. So it's a way to help you remember which ones are negative and which ones are positive. All the cofunctions have negative derivatives. Okay. Alright, so let's let U not just be X, let's let it be something else.
Like a number.
5x.
Oh, I will go with that.
Yay! You just made my day.
Alright. So suppose Y equals the sine of 5x, and you need to find Y prime. Take a moment and see if you can find Y prime.
So we are finding the slope. Yep.
Don't tell me what to do. Jacob, you see below down today? See below down. That's me, alright? You know we're here for you, right? We're a family. Everybody
Okay,
but the
derivative of sine 5x is cosine 5x times 5. Or, to write it a little bit nicer, 5
All of that.
cosine 5x. Does that make sense? Questions on that one? Pretty straightforward. Good. Alright, taking it up a little notch. Suppose y equals the square root of cosine of x squared.
Trying to trip us up.
So the first thing, of course, you would do to differentiate this function is you would rewrite it as cosine x squared to what power? 1/2. Positive or negative 1/2?
Positive.
Positive 1/2, right? So I want you guys to take a moment and find the derivative of this function. What rule are you going to have to use for this?
Chain rule.
Chain rule.
Ew, chain
Bring
ring.
that front down, what's his argument?
Were the quizzes good?
I don't remember.
Whoa. How are you gonna have a negative? No, I'm so confused because it's what?
You write the derivative of the argument.
The overall, the ones that I've graded so far, for the most part, are pretty good. There are a few -20s, and there were a few that got the stamp, right? Not many, but some. Tomorrow, if you get your quiz back and there's a -20 in it, I will give you the sheet that goes along with that.
Okay. We have advanced running. We got a -1.
Did I get -20?
I truly don't.
You guys do anything?
I don't know. I haven't kept track of these, I think maybe in my head.
That's serious.
-20 right here. How are you gonna deal with this negative sign? I don't know how to do this.
Oh, is it true that the final is graded on an AP curve and that it replaces our lowest test grade?
Yes, both of those things are true.
Oh, yes.
My mom made this with like
Okay,
I don't know, like pine straw. Not
So,
add
the
flavor, like add
derivative?
flavor.
write down please. 1/2 times the cosine of x squared to the -1/2. Now we have to multiply by the derivative of cosine x squared. Well, the derivative of cosine x squared is
Oh, wait, no.
negative sine of x squared, I'm going to put them in parentheses, times
1x.
2x.
2x. Yeah, 2x.
Talk to me if you didn't get any of these parts. Okay, so the first part is just chain rule, outside in, so 1/2 times whatever's in there, which never changes, to the negative 1/2, right? Because a couple of you on your last quiz, no, not your last quiz, the test before, did chain rule and did the derivative of the argument inside. It was for the log problem. Yeah, did chain rule and did the derivative of the argument inside. So anyway, the argument doesn't change, right? Then on the outside you multiply by the derivative of the argument. Derivative of cosine x squared is negative sine x squared times the derivative of x squared. Okay, so it's kind of like a multi-layered chain rule, right? A chain rule within a chain rule. Cleaning it up a little bit, I am going to expect a little bit of cleanup. 1/2 and 2, those cancel. So on top we have negative x sine x squared, and on the bottom we have the square root of cosine x squared.
Oh, that looks a lot nicer.
That was what?
That looks a lot nicer.
That looks a lot nicer? Yeah, I think so. Alright, you ready to take it up another little notch?
No.
No.
That was already hard enough as it is.
Oh, we have not even scratched the surface yet.
Oh, was that a Titanic joke?
Okay, now, this next one is almost the same problem, just different function.
We stuff if we were basketball players, I'd be LeBron James and you would be like the guy that warms up his bench.
Oh my goodness.
That was a bad analogy.
That's terrible.
I think I'm a better one now, I'll tell you.
Okay. Alright, so we have the cube root
M.
of the tangent of 6x to the 4th plus 3x minus 2.
I have 9 engines. That sounds like 9 main problems. Okay, chain rule first.
Good.
That's the, that's that thing. Tangent, that's S. Dude, why would you not want to smoke bacon? I have bacon so.
You know what, I got the answers together.
No, I wish.
I got the answers together.
Hey, what's 6 times 4? Is that like
24.
24?
Like the show.
Thanks.
Actually, 23 plus 1.
What? No, that doesn't make sense. That's not how math works. You stop us. This price didn't get it. That was just silly.
Yeah, here in his hands. Do you have hand
No. No.
He's got a little bit.
Why is it only on the sides? Why doesn't it grow like in the middle? Yeah, dude, look at that. Do you see those like black hair, like the 3 black hairs?
Those look like big boys.
Those aren't big. I'm not. I think I'm very big forward. You know, for swimming, you're only supposed to shape the top part of your arm, not the bottom. So it acts as like a gripper when you swim through the water. Yeah. Well, you have a little bit, but you're not supposed to shape it.
Do you use Nair or you shave your arm?
I definitely shave it. I use Gillette Men's Cream, Pro Glide, and then I use the female razors. You have to use the pink ones, because the female razors, they're like softer and they don't cut as much. Like the men's razors are meant to be used in their face. You have to use the pink disposable kind, because like the green disposable kind just sucks.
Alright, so here we go. So first I'm going to rewrite this function
For sure.
as tan 6x to the 4th plus 3x minus 2 raised to the 1/3 power. Okay, so our y prime, doing a chain rule, we have 1/3 times whatever's in there, doesn't change,
Oh, the parentheses are gonna give me every time.
raised to what power?
Negative.
Negative 2/3. Okay. Times the derivative of tangent, which is secant squared. Or x minus 2. Now times 4x cubed plus 3.
Like second semester.
Yeah, that's a pain.
Okay? Now,
I mean, if you're on the border, you won't see that.
Like I heard he bumped his
this tangent goes to the bottom. It's the cube root
I
of tangent squared.
I had an idea with that entirely.
The secant and the 24x cubed plus 3 go to the top. I'm going to cancel this 3 with the 24x cubed plus 3. So you end up with secant squared 6x to the 4th plus 3x minus 2 times 8x cubed plus 1. Talk to me.
Do we have to clean it up for the quiz?
I would like it reasonably simplified, meaning I would prefer not to have negative or rational exponents.
But if we didn't simplify it?
I'm going to say you have to give me answers that are reasonably simplified.
Because like I think the simplifying is the hardest part, to be honest.
That's pretty much true for almost all of calculus.
TBH.
Yes.
That's all we would end up with, yeah.
Okay.
Not what?
I said that's like a totally simplified.
Yeah, that's a lovely simplified.
Zach is an 89 in calculus right now. I'll let y'all know.
That's what he said.
That's actually pretty impressive. Plus the 7 points, you know?
Okay.
That's a
Oh, you
4.
packed out 3.
That is a 4.
All right.
The AP curve.
Suppose y is secant squared of pi x, and I ask you to find y double prime. I'm going to give you a word of advice.
Pi x. Y double prime.
You do the pi thing first, right? Oh no, because it's an x.
Okay. When you have a trig function that's written with this little shorthand notation to a power, and you have to do a derivative, this notation's great. I use it all the time. But when you have to do a derivative, it's misleading. You might want to get in the habit of rewriting your function like that, because this makes it a little bit more obvious that you have to do chain rule than this one. Okay, do you understand what I'm saying?
Yes, some.
Okay. All right. So all I want you guys to do right now in your groups is find y prime. All right? Just y prime. Then we're going to stop. We're going to check your y prime, and then we'll move on to y double prime.
Ooh, this is gonna be tough to simplify. Actually, no, that's pretty simplified right there. Yeah. Oh, you could do like SEC or secant, cosecant, yeah, squared, couldn't you? Yeah. Yeah. Don't tell me what to do. You're not the government. Exactly, did you pay your $300 fee? Your what?
$300 what?
Commitment fee, commitment. You what? Your recommendation.
You get that back January 10th.
That's so late.
I don't know if I'm gonna get in the. Oh, we got that 2020 SAT.
What's your parchment? Percentage.
Probably like a 73. I don't know if parchment like looks at it like early action versus like overall like early action versus yeah, I thought early. I don't care if I can get into that. But my friend Hannah Davis, her brother had.
Okay, are we done?
Got deferred. And
Hannah Davis, that Hannah Davis?
yeah, that Hannah Davis.
Where'd your brother go to school?
And then he got denied eventually. So I was like,
How many A's do you have?
let me ask her. Anna, how many APs did Brandon have?
Okay. So here we go. So 2 times secant pi x to the first times the derivative of secant,
You can get a work
which is secant, tangent, times pi. Now you only multiply by the derivative of the argument once, because you're really doing it times the derivative of this argument, not these, right? This is what we're differentiating, so it's just one time that you do the times pi.
This kid from
You understand that?
he legit pinched
Okay.
Charlie, then-
Did everyone get this? Okay. So if we clean it up, we get 2 pi hush secant squared pi x tan pi x.
I got that.
Awesome. Now we get to do a lovely product rule, right? And a chain rule within the product rule, right? So everyone take, by the way, I'll give you a start. 2 pi, is that a variable?
Yes.
It's constant.
That's
a
what I meant.
coefficient. So the 2 pi can just get multiplied by whatever you get. So everyone take a moment and see if you can find y double prime.
Wait, why is it multiplied not disappearing?
Because it's a coefficient, not a constant.
Okay, okay.
Whoa. How are we gonna do?
Now, the derivative of secant squared you actually just did, right?
You can just copy
You
that.
could just copy this for the derivative of this term right here.
That's what I'm gonna do. Ask her. Well, ask her after she's done with this. You don't wanna intro.
Hey, what was Brandon's GPA?
What? It was a 4.0 with the 7? With and without? Ooh.
Here's my Latin 1 class. He was really smart.
Yeah, well, how is it extracurriculars?
What was his ACT and?
Oh my gosh, guys. Get to work.
I'm almost halfway done.
Be done.
That's 33 ACT.
This is like the longest thing I've ever written in my life. Ooh, 11. Beat you guys. Wait, why are we comparing?
Hey, if you guys wouldn't mind, like, sort of getting annoying. It is getting annoying, so shut up, please. Like, Mark, let's stop. I'm not appreciating it. Let's stop. I'm not appreciating it.
Mustafa, hush. Both of you guys stop. Focus.
I ran out of room this price.
You can go to the next line.
Do you see this? Is this how it's supposed to be? Or did I mess up royally?
I'm gonna see if I can fit it into this space. No way?
No way.
Let's see. Alright, quiet down please. The derivative of secant squared is 2 pi secant squared pi x tan pi x. Now the reason I know that is because we started with the derivative of secant squared and that's what we got, right? Okay. Times tan pi x plus secant squared pi x times the derivative of tangent, which is secant squared pi x times pi.
No, yeah, I messed up. That's why I was so wrong.
Feels though you might mess up like writing this, and then like no one will ever check. I might like lose points. Cause I have sloppy handwriting. I write sloppy on purpose, so like you can't read what I wrote.
I'm pretty sure.
No, that's how I operate.
Benefit of the
So
doubt.
here's what we have.
Alright, tan squared. You can have tan squared. On the
So
first
what we have, just kind of cleaning up for a minute, we have 2 pi secant squared tan squared plus secant to the 4th pi x times pi. So now I can actually pull a pi out.
She's got it, Jacob, for that.
Somewhere I'm feeling like I lost a 2. But
No, I don't
guess-
think you lost the 2. I think you're perfectly perfect. Because the 2 is up front.
Yeah,
You get 3.
okay.
How am I supposed to
You're just not.
Alright, so anyway,
I'm just not gonna
you could leave it like that. I'm gonna pull a pi out. Something tells me I lost a 2 though. On the tape, guys, be careful. See if you find a 2 somewhere. So we could have 2 pi secant squared if we pull it out of GCF.
Wait, what? How'd you get 2 pi squared?
Because I pulled a pi out of each of these and multiplied
Okay.
by the pi out front. And then I'm left with tan squared plus secant squared.
What about, should it be pi tan
Would you
squared?
still have the 2?
No, I pulled a pi out.
Oh, okay, okay.
Would you
Yeah.
still have 2
The 2 tan squared.
Oh, thank you, there's a 2. The reason I'm wondering is because I think either I did it wrong this class or I did it wrong first period, because somewhere I think I ended up with a 2 in both terms in first period. But I think I did it wrong there. Like,
Wait,
this thing's
2
correct
tan
to me,
squared? Where did the 2 come from?
because it was this 2. I couldn't
Alright,
figure
I
this 2
got
out.
you, I got you.
Yeah,
I was just wondering the same exact thing.
yeah.
You stop it, you get that all?
Yeah.
Don't mind the figure.
No erase
Now,
marks.
we're not quite done. There's one more type that we have not talked about yet. Your homework tonight is 3 sections. It's 2-3, 2-4, and 2-5.
Is this notoriously wrong?
Just a, no, it's like maybe a total of around 15 or 20 derivatives. And they're not, certainly not all like that, right? But 2-3, if you remember, that was product and quotient rules. Shh, quiet please. And we hadn't learned chain rule yet with 2-3. So because of that, come on, go out. There we go. Okay, because of that, when you're doing the homework in section 2-3, your arguments are all x. So it's just derivative sine x is cosine x. You don't have to do anything else, right? So it's a little bit easier. 2-4 is chain rule. That's when you get all the craziness with the u's and the u primes. 2-5 is...
Semantic chain product quotient rule. Oh, that's great. Implicit. My favorite.
implicit.
Do you just enjoy being me?
Yes. Okay,
Do you get like a pension bump if you like make a student cry?
yes. For every tear I have to collect.
Are all these types of problems gonna be
Putting your coffee.
That we'll talk about that when we're done. This is the last problem for the lesson, and then we're going to shut off the camera and I'll tell you about your quizzes for tomorrow.
Sometimes the homework is way harder than those quizzes and it scares me.
So it's not like you actually do the homework.
Oh, but I do most of it.
Okay,
but then I
hush,
don't
get to work.
credit.
Get to work.
I forgot how to do this.
Okay, the derivative of sine u is cosine u times u prime, right? Argument stays the same. And then just multiply by the derivative of the argument. Please do not apply a product or sum difference identity to these to try to manipulate your way out of using implicit. It'll make your life much harder. Just deal with it as it's given.
Should I take the log of both sides?
Wait.
Do you think that would make your life easier? No.
I did not do so good on that last test.
That'd be great if you somehow manage to find a problem that makes it have to take the log of it.
Alright, so that's dx dy. Alright, so that's 1
Yeah, Joey.
times dy dy.
Are you afraid to say it on tape?
Like, can you, use like log rules for the sign, like would you use sin x plus sin y, or no?
Does the sine of x plus y equal the sine of x plus the sine of y? No. You cannot change the argument of a trig function without using an identity, ever. The identity would be that sum difference identity for sine, but then you're ending up with major product rule stuff with implicit. So it's actually much easier if you just keep it the way it is. Alright, so derivative of sine x plus y is
Cosine x plus y.
cosine x plus y times 1
times dy dx.
plus dy dx. Is everyone okay with that?
Word to the west side.
Is that okay?
Yeah.
Okay. Remember, the argument doesn't change, right? And then you just multiply by the derivative of the argument. Okay. What's the derivative of 3x?
3.
What's the derivative of 2y? 2 dy dx. Good. Now the way that we simplify this is we have to get all the dy dx's on one side, everything else on the other. But in order to do that, we're going to have to distribute this times this.
No. No.
It's not that hard.
It looks hard.
It's not even a FOIL. It's just cosine x plus y times 1 and cosine x plus y times dy dx. Right?
Alright, you can just
Okay.
you do it and then I'll follow along.
What's cosine x plus y times 1?
Cosine x plus y.
There we go. Don't make things harder than they are. What's cosine x plus y times dy dx?
Cosine x plus y dy dx.
Beautiful.
Alright, when you say it like that, it sounds a lot easier.
It is. I say it because it's true.
When math was this easy all the time.
Okay? We all okay with that?
Sure.
Okay, now we can get all the dy dx's on one side and everything else on the other. So I'm going to move this guy to that side and the 2 to this side, so I have cosine x plus y dy dx minus 2 dy dx equals 3 minus cosine x plus y. Now what?
Take out the dy dx.
Factor a dy dx out. Times cosine x plus y minus 2. And what's the very last thing we do?
Divide out cosine x plus y.
We divide. Beautiful. So dy dx equals 3 minus cosine x plus y divided by cosine x plus y minus 2. Okay. All right. So, homework tonight is 2, 3, 2, 4.